physical file storage. You will be actually distributing it across different kinds of file storages, and we will get to the nitty-gritties of it as we move ahead in this course. But for now, try to understand the basic problem that the engineers at Google, which they were facing, is that they wanted to store in a distributed manner. And for this, they also wanted to run the processes, because if you are storing the data, it should also read the data from somewhere, and then it should store it in a distributed manner also, right? So the processes also need to run in a distributed manner. And this gave rise to very two important things in the big data system that you will understand, that is the Google file system, which has later developed into something known as the Hadoop distributed file system. And to run these processes across the different disks that Google had, they use something known as MapReduce. And what does this MapReduce do exactly? We will look at it later. But for now, try to understand the very basic things. They needed a storage that was distributed in manner, and they needed to run this particular process that would store the data in these distributed systems properly. Now guys, I had gone through this previously, that what are the different types of the data that you usually encounter today. So the first, so there are three main broad categories in it, that is the structured data, the unstructured data, and the semi-structured data. So I think it's pretty clear, guys, what do these three broad categories represent. So structured means you think of a table. As a rule of thumb, it is something that you can store in a table using some kind of, maybe it's an Excel sheet, maybe it's a SQL database, maybe it's some form of table that you can store it properly. Something which is semi-structured is a particular web page. So if you want to really see semi-structured data right now itself, if you go to a particular web page, even on this web page that you are viewing, guys, if you press F12 on it, it will give you a different section in your browser itself, which will tell you what is the source code for that particular page. By source code, I mean what's the HTML going to look like for this page, because what you see in your browser is actually a rendered form of that particular code. It is basically a rendered form of that particular script, which is known as HTML or hypertext markup language, and in which you have these different scripts present inside, which is like maybe JavaScript for running something, or it might be something that it is pulling from the background. So you can take a look at this particular form of data, because this is known as semi-structured data. It will have some structure to it. It will have tags present inside it. It will have brackets defined inside it, where it will tell you where this particular HTML page had started, what were the headers present inside it, and then slowly it will end. And that is what we try to see in semi-structured data, because there is some structure to the data. There are other forms of semi-structured data also. For example, you have JSON, you have the data from social networking website, which are known as like something called as graphs. You have emails, you have server logs. These are all different kinds of semi-structured data. And if you look at unstructured data, it basically means that something that doesn't have any structure to it at all. Like if you try to open an MP3 file in a notepad, guys, you will be able to see lots of characters and codings present inside it. It will not actually make any kind of sense, and it's very difficult to decipher what they have actually done in that data. And that is what we mean by unstructured data, something which does not have any kind of structure present inside it. And these are the different kinds of examples of data that you can find below structured, unstructured, and semi-structured data, which is like timestamp data, machine data. You have spatio-temporal data. You have open data that is present across the web. You have dark data. You have real-time data, genomics data, basically, which means that something you get from genes, or like which they use it for They use it for storing the genomics data of different kinds of organisms that are present. There is operational data and so on. So these are some of the examples of the different types of data. So the key important takeaways from here are the Google file system, which will help you to store data in a distributed manner across multiple interconnected computers, and the process to run these these methods so that you can store this data in a distributed manner across multiple interconnected computers, commonly called as MapReduce algorithms. Let's look at some of the main 5 characteristics of big data. Now, some people might call it as big 4 V's, or you can define it using the 5 V's of big data itself. And they are namely volume, velocity, variety, veracity, and value. So let's look at volume. So what does volume essentially mean? By volume, you mean the size of the data. Big data cannot be stored, processed, or interpreted by a single computing system or a single computing machine. And that's what volume essentially means. So how do you represent volume? You represent volume in terms of terabytes, petabytes. That's the unit for measuring the amount of data that is present in a particular system. And how is the volume stored? Using records, or you can think about a different architecture of how the data is stored. It might be columnar, it might be row wise data, and it is defined by what are the transactions done on the data, and how are you storing that volume of data, the representation overall of it. I mean, whether it is files, whether it is tables, and that is what we represent by volume of data. The next important point, velocity. And as you might have guessed it already, velocity basically means the speed at which the data arrives. So a big data system is expected to process data at such a high speed. The system should essentially be capable of accessing, storing, and processing data at high speed. And for that, we have something called as batching. And velocity might also represent something like, it is almost happening at real or near time, and the different processes, or you can think of it as streaming data also. You might have seen many streams in YouTube where uh, the video is actually of very high quality. Let's say many people across the world are viewing the video in 4K. Now that itself is a huge problem, because 4K means that there are lots of pixels present inside it. You are taking the data from the camera, you are processing it, you are adding some kind of layers to it, and then you are broadcasting it. That itself means that there is a huge amount of data that needs to be sent at a very high speed, and that is what we try to signify when we talk about velocity of the data. The next important point is variety present inside the big data. Now, you might have a preconception that big data essentially means that there will be actually huge tables, but that's not true, right? Because we just discussed about the different kinds of data. It can be structured, it can be semi-structured, or it can be unstructured data. So systems should be capable of handling all these different kinds of data, and that is one of the main characteristics of a big data system, is that it should be able to handle a huge variety of data. Last but not the least, the most important point about any kind of data is to understand what is the trustworthiness of the data, what is the authenticity of the data, and how good is the data that is captured by a particular system. Because the data should not be lacking in terms of quality or authenticity, because that would mean that you will not be able to generate any kind of useful insights from it, right? Because your data is not as authentic. So if data is prone to noise or bias, you should be able to clean it, you should be able to vouch for the data, and that's what veracity means from a big data source. So just to summarize once again, when you talk about the four V's of big data, the first thing is volume, velocity, variety, veracity, and last, you try to derive the value from the data. Whether it is, some kind of statistical insights from the data, whether you try to, decide what kind of events can be triggered from the data, if there are correlations across the various points in the data, and whether some of the assumptions are hypothetical in the nature. Let's take a look at the different applications of big data in various domains. So, big data, as you know, can be used in healthcare. Big data can be used in manufacturing. Big data has applications in media and entertainment. Big data has applications in IoT. By IoT, I mean Internet of Things. And big data has applications in the government sector also. So, for now, let's try to look at two different examples from the finance industry. Now, one of the main problems with any kind of finance industry is, lots of data